Okay, so the next type of transformation here, and once again we've seen this before with other functions, is a vertical stretch or shrink. So this is where we have a number in front of our function, which we're going to call a. So recall that because we're multiplying the function by this so-called a, that means the y values get multiplied. All right. So you're multiplying a function by a, that means you're multiplying the y values only, and x stays the same. Recall that if that number in front is negative, we really have a reflection over the x-axis. Now, if we just think about it as being a positive number only, so the absolute value of it, if it is greater than 1, then we have a vertical stretch. Okay. By the way, if it is 1, then it's not changing the original function of sine of x. Okay. If the absolute value of a is less than 1, then we have a vertical shrink. So we're talking about a number like a half. Okay. Now, the absolute value of a, that number a in front, is really what we call the amplitude. Okay. So if you were to take a look at something like y equals 3 times the sine of x, well, in this case, it would go all the way up and all the way down. All right, here your new max would be 3, okay, at this point, and your new min would be down here at negative 3, okay? So here we would say that the amplitude is 3, okay? If we were to look at y equals 1/4 times the sine of x, all right, this would be a vertical shrink. Okay, so now we would be looking at something that might look like that. Okay, so vertically it's shrinking, so now it's only going up to a positive 1/4 and going down to negative 1/4. Okay, so your amplitude here would be 1/4. So it's still ending at 360 or 2 pi. All right, if I were to draw this to scale, it's not changing horizontally. Okay, pretend that this distance looks the same as what I drew down here. I don't mean for the second one to look longer. Okay, they're both ending at 360. Okay, so the period, all right, is not changed. All right, so if we compare the original graph of sine of x and we throw a 3 in front or a 1/4 in front, it's still going to complete its full cycle by the time it hits 360 or 2 pi. Okay, the number in front here is just affecting the y values, so vertically we say it's either stretching or shrinking. Okay, our last type of transformation here deals with a horizontal stretch or shrink. So this is a change on the inside of our equation. B is showing the type of change that's happening. So this is where we have a number on the inside, something like the sine of 3x or the sine of 1/2 x. So what's happening here, again, this is the same idea from earlier in the course when we studied other types of functions. Recall that the x values get multiplied not by b, but actually by 1/b. Again, the idea of an opposite, right? We saw with a translation that if we saw the sign of x minus c, it was really shifted to the right c units, right? So the idea of being an opposite. So here, the x values get multiplied by 1/b, or you could also say they're just being divided by b, and the y values would not be affected. Okay, so only x gets affected. We're talking about a horizontal stretch or shrink, so horizontal refers to x. All right, so if we are making an adjustment horizontally, the period is going to be changed. Okay, remember the period is the length of time required to complete a full cycle. Okay, so if we are stretching things or shrinking things horizontally, then the period or the length of time, the number of degrees required to complete a full cycle is going to be different. Now, you may recall from last year that we used the term frequency for that variable b that we see on the inside. And you need to know that the frequency is really referring to the number of cycles from 0 to 2 pi. All right, that's if we're talking about sine and cosine. Okay, so if we're talking about tangent, by the way, the frequency would be the number of cycles from 0 to pi, right? 0 to 180. Doorbell. Hang on a second. All right, so where were we? Here's a nice spot. So if b is negative, all right, so if we have, remember, if we have a situation where you have f of negative x, right, that's really what's happening here. If b is negative, we said that's really a reflection over the y-axis, okay? So let's just look at the absolute value of b. So we're going to ignore any possibilities of it being negative. So if it's a number greater than 1, then we're talking about a horizontal shrink. And if you are shrinking your graph, so imagine your basic sine curve, and then you are shrinking it horizontally. What that means is a complete cycle is going to happen in a shorter time period. So that means the period is going to be shorter. Okay, so if you're shrinking it horizontally, the period is going to be shorter because there's less amount of time required to complete a full cycle. Now, if your frequency is something less than 1, like a half, well, this really means that it's being stretched out. So if your b were a half, then you're multiplying your x values by 2. So that means it's stretching horizontally, which means it's going to take longer to complete a full cycle. So the period would increase in that situation. Alright, so if we were to combine all of our transformations that we just looked at, if we were to look at this general form here of an equation, okay, we have sine on the inside here as our main function. The a in front, the absolute value of it is going to be our amplitude, recall, and we said this is your vertical stretch or shrink factor. Okay, that's what you're going to multiply the y values by. The b is what we call the frequency. This is your horizontal stretch or shrink. And recall we said that this is by a factor of 1 over b. The c on the inside here, next to the x, this is your horizontal shifter. So this is moving it left or right. And the d on the end is your vertical shifter. And remember, this is really going to give us our principal axis. Alright, last example. Suppose we're given this function here, y equals -5 cosine of 2/3, and then we have x plus pi in the inside, and then all that minus 2. We are looking to find several different things here. So let's go through them one at a time. Amplitude. Well, remember we said the amplitude is the number in front, but be careful, it's really the absolute value of the number in front. So it's the absolute value of -5, so it would just be 5. Okay. Now recall that this is equal to 1/2 the max minus the min. Okay. So the amplitude, that vertical distance between the max and the min there, looking at 1/2 of it, would be 5. Now the equation of our principal axis. We know the principal axis is a horizontal line, and so it's always going to be y equals if that's the case. And we said this is going to be your number on the end. So y equals -2 would be the equation of your principal axis. Alright, so while we don't know exactly what this graph looks like, we do know that down here at y equals -2 we have our principal axis. Okay? So that's the center line, it's the line that is going through the middle of it. Keep in mind that this is equal to 1/2 the max plus the min. Okay, it's going to be the average between your max and your min. Well, what is the actual max and min? Well, keep in mind that we said we know the amplitude is 5. Okay, and if the principal axis line is -2, then remember we said the amplitude is that vertical distance from this axis line up to the max and then down to the max. So to find the maximum value, we're starting at this -2 line, and then if we were to add 5, we would get 3. So that's the highest this graph would reach, all right, in terms of its y value. The minimum, well, we're starting with this -2, all right, this principal axis line, which is in the middle. And in this case, we're going to subtract 5 to see the lowest that it's going to stretch. Okay, so the lowest it's going to go would be -7. Okay, notice how if we were to check this, okay, if we were to do the max minus the min, you would get 10. Half of 10 is your 5. And if you were to average the 3 and the -7 together, right, if you were to add them up, you'd get -4, and then -4 divided by 2, you would get your -2 for your principal axis. Okay, so to find the max and the min, we're using our principal axis number and our amplitude. Alright, our frequency, this we said is the B. That's just the number that we see on the inside there. Okay, so that's just 2/3. Alright, now the period. Okay, we said this is the length of time required to complete a full cycle from 0 to 2 pi or 0 to 360. Alright, well, we have a formula for this. You may recall it being known as 2 pi over the other guy. Well, the other guy is the frequency. Okay, so it's 2 pi over the frequency of 2/3. Okay, so 2 pi divided by 2/3 is the same as multiplying by 3/2. Those will cancel, leaving us with 3 pi. So it would take a distance of 3 pi in order to complete a full cycle. Okay, kind of makes sense since here we see the frequency is 2/3. So 2/3, all right, we would see 2/3 of a cycle by the time we hit 2 pi. So we would have to go all the way out to 3 pi to see a full cycle. Okay. By the way, your frequency, this is also 2 pi over the other guy. Well, the other guy is the period, right? So if you did 2 pi over the period of, well, we found it to be 3 pi. All right, notice how that is 2/3. Okay, that's it for now. Bye-bye.